Hi, my name's Dave Oram, and welcome to my series on production grade systems development. In this episode, we're going to be building up our development environment. If you haven't seen my earlier videos, I encourage you to go back and watch those to give you a bit of an introduction of what we're building, which is a small microservice. So today we'll be covering off what it's like to build a development environment in 2025. If you'd like to follow along, point your browser towards github.com/davidoram/beaker. Then navigate through the README to the file called developmentenvironment.md. Click through to that. That'll show you what we're looking at. So what is a development environment? It's where your developers, testers, and infrastructure engineers write, test, and debug code. A good development environment contains all of the tools and resources you need to build, debug, test, run the application safely without affecting your colleagues. Ideally, this means that each person can work concurrently on separate features or bug fixes without impacting others. Isolation of your test development environments helps people work at their own individual speed without being blocked by others. I've worked in many places in the past where there was always some part of the system where developers or testers bumped into each other. Often this happened at the data layer. For example, multiple testers and developers might be working against a shared database. This kind of slows down development because of issues such as each developer or tester must be careful not to overwrite or change someone else's test data. You might struggle to coordinate database schema changes if they impact others. Performance testing becomes impacted by other people's workloads, so accurate measurements become much harder to obtain. All of these issues lead to increased friction and decreased productivity. So, our goal is to create a completely isolated development environment. It takes a lot of effort to create a development environment. Consider what happens when a new person joins your team and they need to get their development environment set up. So it might involve getting them a new machine, installing the correct version of the operating system and updating it, installing any containerization software such as Docker or Podman or Kubernetes, then popping on a code editor or an IDE such as VS Code or Vim, and of course we need our source code control tool, for example Git. Then we might need a bunch of compilers, for example C#, Python, or in our case Go. Now we need a place to store our database, so Postgres, MySQL, and of course your associated client tools that allow you to access that database. Then pretty much every software system is going to have some kind of specialized tools. Maybe they help you develop documentation, generate code, perform linting, and so on and so forth. And of course, wrapped in all of this is the kind of credentials you need to access the other systems that your software developer needs. So they need access to your GitHub account, maybe a Jira system for ticketing, and any other sort of cloud providers, for example, AWS or Azure. So once you've done all of that, you're just about ready to check out the source code on your application and start working. Quite a process. The issue with all this setup is you end up with a bunch of problems. First of all, you've got complex setup. Each new team member needs to grab a very long checklist, install all the required configuration tools, configure them, put all the dependencies, get all the credentials sorted out. Next, there's a bit of a maintenance burden. So like with all other software systems, your development environment now has to be kept up to date. So for example, you want to make sure everyone's upgraded to the latest version of, say, Postgres. Now this is difficult and can get inconsistent across your team, which can lead to subtle problems. And then you've got the problem of troubleshooting difficulties. So diagnosing and resolving environment-specific issues is hard enough, especially when the problems are unique to just one person on the team. Like I mentioned before, you've got lack of isolation. So where your development environment has some sort of shared resource like a database, It leads to conflicts, maybe data corruption and reduced productivity. This leads to an issue with experimentation risk. Trying new versions of tools or languages can disrupt existing setups, making it really hard to safely experiment without breaking things. Remember, our developers, testers, infrastructure engineers want an environment they can work in. And if they're worried about going down the path of an experiment, if they're worried about being able to get back to something that works, that's going to cause them to question, can I do the experiment? Do I have the time to undo things if go wrong? So it affects productivity, and it's a barrier to experimentation. So summing up, setting up and maintaining a consistent, reliable and isolated development environment is challenging, can lead to wasted time, hard to diagnose issues, and friction for both onboarding people and for their day-to-day work. So that's why many development teams, including myself, have moved to online, cloud-based development environments. The idea behind this is that a team builds a standardized development environment, typically using containerization technology, and then when the developer needs an environment, they spin one up, they use it for the duration of a piece of work, and then they discard it once they're done. Each cloud-based development environment runs in the cloud, but looks and acts just like a normal development environment you'd run on your laptop or your PC. So, many vendors offer some service like this. The one that we're going to look at today is called GitHub Codespaces. If you scroll down the page, you'll see a diagram showing the GitHub Codespaces environment that we'll be running. GitHub Codespaces runs either in a local copy of VS Code or directly inside a tab of any modern browser. For example, Chrome or Safari should work fine. When we start a Codespace, a virtual environment is initiated somewhere inside GitHub's infrastructure on our behalf. On that machine, it has the following. First of all, it has Git and all of the source code for the Beaker project checked out. Next, it has a bunch of tools installed on it. Go compilers, all the command line tools that will be needed to build, run, test our system. It also has a full Docker environment. And inside the Docker environment, we're going to run Postgres. This is to hold our tests and our production database. You wouldn't do that normally, but for the purposes of this, we'll run our production database inside the Codespace. You'll notice on the left of the diagram, you see that our particular Codespace will connect to some other services running on the internet. First of all, it'll connect to Synadia Cloud. That's our NATS service. Next, it'll connect to uRelic, which will store out all of our OpenTelemetry traces and logs. It connects to GitHub for recording source code changes. And what's not shown on the diagram but is possible is Codespace has something called automatic port forwarding. For example, you could choose to run a website on your Codespace. Forward the port for that website so you can make it visible to your local machine. So, what are the advantages of our Codespace environment? First of all, your developer only needs a browser and an internet connection to get up and running. This makes onboarding sort of like a one-click operation. So, your IT manager might issue a Chromebook or a MacBook Air instead of a really expensive PC or a MacBook Pro, for example. This offers significant hardware cost savings. Each developer's environment is completely consistent on setup because we script it. This gives us confidence to be able to experiment, make changes with the knowledge we can always back out if things don't work. It's not just the software we can change, but we can also change the virtual hardware. So it's trivially easy to increase, for example, the number of CPUs and the amount of memory in a Codespace. Lastly, developers can run a number of independent Codespaces concurrently. So you've got a couple of tasks you're working on, you can run up separate Codespaces for each of them, and then just pause one when you get blocked on that, switch over and work on another one. So we've talked about the advantages, but it's good to be aware of the disadvantages. So maybe the first one, and maybe the most controversial one, is that will your developers accept a standardized set of tools? This is kind of especially relevant when it comes to your IDE. So Codespaces work best on VS Code, but they've got like a beta support for JetBrains IDE. But what does that mean if you've got a developer that likes to use Vim? Next is that Codespaces cost money. Personal accounts get a quota of free usage, and it's very affordable. For example, I've been using Codespaces for this project, working just in my spare time, and my bill last month was 49 cents. Of course, when you move to an enterprise plan and you're getting more serious about this, they cost real money, so that needs to be factored into your equation. I've been using Codespaces at my day job for almost a year now, and for me it works extremely well. You'll need to make your own judgment about how it will work for you and your team. Remember, seek wise counsel and own the decision. Okay, let's dive into the Beaker project Codespace settings and examine step by step how it's all put together. So in your browser, if you click on the link to open the dev container JSON file, if you've checked out the project already, it lives in the .dev container directory in the root of the project. Okay, we'll start off with the name attribute of our project. This is informational only, so I just called it the Beaker project dev container. Next, the workspace folder shows where all the application project files will live. Moving down, the feature section pulls in pre-packaged tools. There's lots of them to choose from, and I've added some links into the documentation. This is the simplest way to start adding pre-built tools into your development environment. So I've added the Go development environment and something called Docker in Docker. The Go feature adds all the Go programming language tools. Docker in Docker runs a Docker daemon process inside your code space, which is running in Docker. The next section is called forward ports. A forwarded port moves network traffic from one computer to another. And in this context, it's telling the code space to forward the network traffic from the Codespace virtual machine to the developer laptop. So, port 5432 is used to query the Postgres relational database. By forwarding this port, it means I can run queries from my laptop. They'll be redirected over to the Codespace and forwarded to the Postgres server that's running there. So why is this useful? Sometimes we prefer to run a tool that's native to our laptop or our PC, but have it interact with things that's running on the Codespace. And in my example here, I've got a Postgres query tool that I really like. It's called Postgres, and I want to run that directly on my Mac and have it connect into the Codespace. The next configuration value is customizations. Here we've added some VS Code specific extensions there. These extensions customize the editor, and by adding them into the Codespace, it means everyone who starts that Codespace will get the same extensions. So I've added the official Go extension, which will give us things like syntax highlighting, code navigation, testing and debugging support. The other extension, which is more of an experiment for me, adds support for editing mermaid diagrams inside Markdown. This is a good time to discuss documentation formats. I like Markdown for documentation tasks because it's so lightweight, easy to read, it's plain text, and it automatically renders with formatting when you're looking at the GitHub projects through the browser. So if you look at the raw versions of Markdown files, you'll notice that some diagrams are defined textually using the mermaid language, which harks back to a point we talked about in an earlier video where we prefer to use textual formats for our data. And in this case, diagrams are just another form of data. The beauty of using the mermaid format is, again, GitHub will render those diagrams for you when you're just viewing it in the browser. So it's kind of a super simple way to define diagrams in your text and also leverage GitHub's ability to render them for you so you can share them and view them easily. Also, when someone edits that diagram, because it's textual, you can see the diffs of what's changed very easily. Choosing a text-based format for documentation reminds me of that saying, "Blessed are the simple, for they shall ship on time." Right, we're coming towards the end of this file. So we have two configurations entitled onCreate command and postCreate command. Each of them refers to a separate shell script. These scripts run at different times during the dev container lifecycle. onCreate command is used for one-time setup. Postcreate command is sort of after you've started up a container. Okay, let's have a look at what they run. Open up the onCreate command shell script. The first line tells us it's a bash script, and it has some documentation at the top, and then it runs make. So this brings us to make. If you haven't encountered it before, it's a Unix build automation utility that runs commands defined in a make file, typically to compile applications or run repetitive commands. I've used make and make files for many years, but the choice to use it is largely personal. There are probably better tools out there, but at this stage, I'm using what I know. Okay, so our commands will run make setup, which runs a target called setup inside the make file. If you open up the make file, you'll see some preamble at the top of the file. Just scroll down until you find the line that says setup : ... This is a target. When the command runs, it's going to find the target specified and run any dependencies. Those are other targets that are to the right after the colon of the setup. After it's run the dependencies, then it will run the commands specified under the target. So we've got a couple here. They install tools using the apt-get, and then they install some Go tools. apt-get is like a Unix installer tool. You can probably guess what the Postgres SQL client is. It provides command line access to the Postgres database. Get's obvious, that's for our source code control. And JQ is a JSON query tool. JSON's our data format that we'll be using through our system. And so we show you the use of JQ in a later video. The Go tool install commands is a feature of Go which allows you to specify GitHub projects as tools that you want to be installed. So when you run this command, it'll download the tools, compile them, and install the resulting binaries inside your code space. So they'll be just sitting there ready to run. If you're interested, Go tools comes from the tools section in the go.mod file. Okay, that's the end of the setup, and we've got all the tools we need installed. Remember, all this tool install setup happens exactly once. It's part of the onCreate command. Now we're going to flip over and look at what happens in the postCreate command. Open the postCreate command shell script. The first non-comment line calls set-e, which tells the script to exit immediately if any of the commands inside it return a non-zero exit status. Now this might not be something you've seen before. So if you're new to Unix-based systems, what happens is whenever you run a command in Unix, the convention is that it sets something called a return code, which is an integer number. The convention is that if the command returns a 0, that means it kind of worked okay. Any other value means it's had an error. If you're new to software development on Unix, it's worthwhile studying its tools and the way they work, because it's good to remember the ancient paths, where the good way is, and walk in it. Even as an experienced developer, I learned a lot from Eric S. Raymond's book, The Art of Unix Programming. It covers a lot of the thinking and the philosophy behind these Unix systems, and it's been a really strong influence on my thinking. Okay, back to the code. We have an if statement that checks for an environment variable called $GitHub Actions. The GitHub Actions environment variable is set when we employ the GitHub infrastructure to automatically run my tests. We'll cover that more in a later video. The -z option will be true if the GitHub Actions environment variable is empty. When the Codespace environment starts up, it will be empty, so we'll run the commands inside the if block. Git pull origin just makes sure that our Codespace has all the latest code changes pulled down into the Codespace. Okay, next we've got a loop that iterates over environment variables that are prefixed with a nats creds underscore. For each of these variables, we base64 decode the value in it and save it into a file inside the home folder. Base64 encoding and decoding is a standard way of sharing data on the internet in a kind of a safe way. The advantage of base64 encoding is you can share any sort of binary value and it will just be represented as ASCII strings. So that makes it perfect for sharing inside environment variables. Now, the values that we're sharing here contain secret credentials that we'll be using to connect to the Synadia Cloud NATS system. You might be asking yourself, well, where are those values coming from? In a later video, we'll be signing up to Synadia Cloud and creating some credentials. Then we'll add those credentials as Codespace user secrets. It's super important never to commit credentials like API keys into our GitHub's source files. So, luckily, GitHub provide the Codespace user secrets mechanism, which allows us to save them into a safe place where no one else can see them. Then, when you run the Codespace, they'll automatically be injected in there at runtime. Let's say we've got two users, Jill and Bob, and they're each creating a Codespace from the same repo. When they set up their own Codespace user secrets, they'll get their own individual values. You'll see that inside the loop, after the values are saved to a file, we call the nats context add command. This registers nats credentials with the nats CLI tool, so we can have those credentials available for selecting later. So this marks the end of our startup sequence. Right, so there's just one more command to run, which is make bootstrap. This will run up all the services that need to be running for our development to start. In our case, we need the Postgres database to be running and to have two databases created. One for development called beaker_development and one for unit testing called beaker_test. Before we delve into the bootstrap target, I need to talk about Docker because it's the first time we've used it. What is Docker? It's an implementation of the Open Container Initiative standards, and it allows us to package up a full application, including all the libraries, code, and other dependencies, into a portable format called a Docker container. Then that can be run consistently across different environments like PCs, Macs, or server machines. Docker implements the OpenCI standard, but there are other implementations like Podman and Kubernetes. Our whole Codespace environment is running inside an OCI runtime on GitHub's infrastructure. We'll be using Docker to run the Postgres database. So Docker is a pretty key component in modern software architecture because it simplifies the way that we can package software for use on a wide multitude of systems. Docker Compose is a tool that comes bundled as part of Docker. It lets you define and run multi-container applications using a simple configuration file. So you can start everything you need. Like you might need a database and an email server. You can start them with a single command instead of running each container manually. So in our case, we're only using it to run a database, so it actually might be overkill. Anyway, back to the bootstrap process. So bootstrap depends on the restart Docker Compose target. And that target is dependent on two other targets, Docker Compose down and Docker Compose up, which are run in that order. The Docker Compose down target will destroy and delete our Postgres server environment and all of the data in the databases. This approach of deleting everything and starting from scratch is great for development and test environments where you don't have any data that you need to retain. This is great because it forces us to understand our data requirements and then turn them into repeatable scripts. Once you've got a scriptable environment, it's super easy to share with others and have them configure so they can test their system in exactly the way as you have. The docker compose -f command takes the docker compose YAML file, then we specify down and we say remove orphans. Then we've got 2 vertical bars and true. So this is saying, telling Docker to use that file to run the down command to stop all the containers inside it. The remove orphaned flags tells Docker to kill any unconnected containers. The or true is really important because make will stop any command that returns an error. And at this stage, we don't really know the state of the Docker environment. We just want to delete everything, get back to a known state of being empty. So after this command runs, let's just take it for a fact that our Docker environment isn't running anything. Before we run our Docker Compose up, it's time to examine the Docker Compose YAML configuration file. It's inside the .dev container folder. So a YAML file is like a human-friendly text format that's used to represent structured data with indentation. YAML is often used for config files, and this file lists the services that we want to run inside Docker. We've only got one service called DB, and inside that it specifies the image, which is the Docker image of the program we want to run. The format of a Docker image is name:version. So you can see we're running Postgres version 18. The restart step tells Docker to automatically restart the app if it crashes, but not if it's explicitly stopped. And then further down in the environment section, we've got a list of key value pairs, and they're turned into environment variables that are passed down to the Postgres image when it runs. The port section is where we expose access to the application through TCP sockets. TCP sockets work across machines that are connected through a network. They use IP addresses like 127.0.0.1 and then a colon and then the port, for example 5432. So when Docker runs this image, it's treated like a remote machine, and any application running on the dev container will need to connect through a TCP socket. Returning to the make file. After we've run Docker Compose down, there are no Docker containers running. So next it runs Docker contain up. This will create all of the containers in our YAML file. The -d option means detach, which tells the Docker Compose command to run the containers in the background and then return back. Returning back to the bootstrap layer, now that we've recreated our Postgres environment, we run a couple of strange looking commands, $brackets make recreate db, db equals development, and the same again with db env equals test. What this means is we're asking make to call itself with a specific target, for example recreate db, and we want it to pass an environment variable db-env set to a particular value. So let's look at the recreate db target. If you scroll down, you'll find it in the middle of the make file. So it's dependent on 3 targets, which you have to run in order: drop db, create db, and then migrate db. And then after that, it just uses an echo command to print to the terminal. Drop db is dependent on Postgres ready and terminate cons. After they've run, it uses the psql command to drop the database, using the db-env environment variable to drop either the beaker development or beaker test. Hey look, we're jumping the gun a bit though, because we need to look at the dependencies first. Postgres ready uses the pg isReadied command to wait for Postgres to start up, or wait 5 seconds if it's not ready, which will give it some time to sort of maybe start up. Then the wait for it tool waits 30 seconds for Postgres to be ready to accept connections on port 5432. All this is about is giving Postgres some time to bootstrap and then start its network subsystems. Once those two commands have passed, we know Postgres is up, it's ready to accept work in the form of SQL commands. Terminate cons uses the PSQL command to run a SQL script that terminates any active connections to our Beaker test or Beaker development database. But why do we need to do that? It's because Postgres will prevent us from dropping a database that someone's connected to. So we want to force all of the connections to drop. So this is all about making life more convenient to the developer. If you didn't do this and you try to recreate your development environment, you'd have to manually find any processes that are connected to the database and shut them down manually. Backing up a bit. Now that we know that the Postgres database server is running, ready to accept network connections, and we've terminated any existing connections to that, next we want to run createDB. So this target issues the SQL create database command. This command creates a brand new, clean, UTF encoded database called Beaker Dev Development or Beaker Test. It's owned by the Postgres user and has the standard US English locale settings. We'll discuss some of those settings a bit more in a future video. Suffice to say, we've created a fresh database. It's got no tables and no data in it. Last but not least, we run the migrateDB command. Now we're going to touch a bit more on this in a later video, but for now, just accept that the fact that it's going to create all of the tables and all of the data we need to start with a fresh, clean database. So that rounds out the make bootstrap command. But for those of you that are observant, you might be wondering, why don't we just run that as part of the post-create startup sequence of the code space? Well, I wanted to do that, honestly. I had a lot of trouble making it work reliably. The problem seemed to stem from being able to make sure that Docker daemon was fully start up before I start asking it to run Postgres. So I spent quite a bit of time getting this going. And then I opted for a workaround, which was just that the developer has to run make bootstrap when they start or restart their code space. So this is something that often happens in real life development. We might encounter a problem that stops us from achieving some sort of bigger goal. So sometimes a manual workaround is fine if it helps us keep moving. We can always circle back later, tidy it up, or automate it once the pressure's off. So the lesson here is that sometimes we can make a pragmatic call in the short term as long as we don't compromise our long-term quality of what we're producing. So for me, in this situation, my decision was that having an extra step for the developer to set up the environment is okay, because ultimately that won't compromise the build of production quality API code. So just to emphasize, the point of running make bootstrap is something we can do at any time to recreate our system with databases that have their structures set but completely empty of data. If we're experimenting and we break things, it's a quick and easy way to get back to a known state. So systems like this encourage experimentation because we can always recover things easily and quickly. Not everything needs to last forever, just long enough to serve its purpose. As our development environment becomes more and more complex, we need more tools and more libraries, more applications to run in order to do development. Installing all of these tools will slow down the creation of our code space, and that impacts our productivity. The folks at GitHub have got a trick up their sleeve that we can use called pre-built dev containers. A pre-built dev container has the dev container image built in advance to speed up your container startup. So let me show you how that's done. Navigate to the GitHub project, click on Settings, Codespaces. Then you can see we have set up a pre-built container for us to use. If we click Edit, we can see how it's set up. It runs only on the main branch, specifies the path to the dev container configuration to use. In the Triggers section, you can specify what will cause it to be triggered, and I've set that to be when the dev container configuration changes. In some other situations, you might want to do it differently. Say, periodically 6 AM every morning, so that when your team starts work for the day, you know there's always a fresh dev container ready to be run. The other settings down below allow you to configure where the image will be available. I've set mine to Australia, so I hope you're able to use that from where you are. If not, maybe pop a comment on the video. The last setting is a useful one, and you can specify to notify someone if your pre-build fails. Okay, let's click back and view the output to see how much time the pre-built step takes. Click on the See Output button, and it shows us that the pre-build took about 30 minutes. Wow, that's quite a significant amount of time. So let's now run up a dev container in the browser and see what that looks like. Okay, I'm going to run up a new Codespace in my Safari browser. Whatever browser you're running, I advise you to check it's running the most up-to-date version before starting. Okay, to run a Codespace, we start at the Beaker homepage in GitHub. Click on Code, then Codespaces. And then I'm going to click the plus button. It starts a new copy of VS Code, and then the terminal you can see it running the post create command. After about 15 to 20 seconds, it tells us that it's finishing configuring the Codespace. Wait, why did it start the Codespace in VS Code and not in a browser window? That's because I can set a global preference against my GitHub profile. Go to Settings, Codespaces Editor, and you'll see the preference. Okay, let's see what we have. On the left in VS Code, the File Explorer shows us all the files we've checked out of Git. At the bottom, we can see that we've checked out the main branch. That can be changed by the usual Git commands, or it can be set by creating the Codespace when you have another branch selected in the browser window. Let's check if all the tools are installed. Start with Terminal, and you can run go space version, confirm we've got some Go tools, JQ-V to confirm that JQ is installed. If something goes wrong during your Codespace startup, you might be wondering how you debug it. If you watch closely, you might have noticed a message come up which tells us how to open the full logs. So let's go and have a look at that startup sequence. You can scroll right to the bottom of the page and then up a little bit to see the last steps. Like we talked about earlier, our Codespace is started up. The last step is manual. We need to run the Docker Compose step and finish creating our clean environment. So let's do that now by typing make bootstrap. We can confirm that's run okay by running docker ps. That shows us the processes that are running inside Docker, and you should see Postgres in there. Well, so that brings us to the end of this video. We've covered a lot. So let's just have a quick summary of what we've found out. So first of all, Codespaces run in the cloud. Provide its user interface either through a local copy of VS Code or through your browser. The minimum you need though is just a modern browser. We start Codespaces on demand via the GitHub web interface. And we know that when they start, there are two distinct phases. The onCreate command is run exactly once, and that's where we'd install any tools. And then the postcreate command runs each time a Gitspace code starts up. Our Codespace environment makes the development environment consistent for everyone. We can run it on low-cost hardware and then tune our virtual hardware to suit our needs. I can shut down a Codespace, open it up on a new machine, and it's exactly where I left it. Any files that are left edited, not committed, etc. will still be there. The downside of using a Codespace is that I can't use it when GitHub infrastructure is down, and that sometimes happens. Right, so that brings us to the end of this part of the video. If you've opened a Codespace, then you can shut it down now. To do that, close your window in the browser, or in my case, I'll close VS Code. The Codespace will be running until you explicitly shut down, or it'll shut itself down after a period of inactivity. The important thing to note is that if you have edited files inside your Codespace, they'll be retained until your Codespace is fully deleted. So it's perfectly normal for you to just edit some files one day, save them, and just restart your Codespace the next day and pick up where you left off. If you want to delete the Codespace, go back to GitHub where you created them, click on the code button in the Codespaces, and then the ... button will give you the option to delete the Codespace. GitHub kindly offers a free quota of 120 hours a month to use Codespaces, which I think is pretty amazing. It means we can all have a play with this amazing technology. So in summary, we run our dev environments inside Codespaces. They give our teams consistent, reliable and stable environments to work in. Team members create them, use them for a specific task, and then discard them. Tooling's consistent right across the team. Onboarding's easier because we can give people a reliable, consistent development environment quickly. The downsides are that we're forced down a particular set of tools, most notably using VS Code. So this might turn some developers off, particularly if they really love the particular tool set that they're used to. We've learned how to create a Codespace, we know the life cycle they go through, and we know how to use pre-builds to speed things up. We can debug a Codespace startup issue, and we can keep things clean by deleting our Codespace when we finish them. Thank you all so much for listening. It's the end of our video on development environments. Remember, iron sharpens iron and one man sharpens another. Hit the subscribe button if you want to be notified when the next video is out. In that video, we'll be starting to talk about data. Thanks for watching.